Whenever you deal with electricity, there is always a risk that something might go wrong. And one of the most common issues that can occur are sudden increases in the electric current, which we refer to as surges. These surges can take place for a variety of reasons, such as when something changes within a circuit. For instance, when you turn an electrical appliance on or off, or they can be caused by faults within the wiring or within the appliance itself. Aside from potentially damaging the appliance in question, surges can also be much more dangerous, sometimes resulting in fires or electric shocks, which makes it critically important to implement safety precautions designed to minimize these risks. In this explanation, we will cover some of the key electrical safety features that have been developed for this purpose, including fuses, circuit breakers, earth wires, and the concept of double insulation. Both fuses and circuit breakers serve a very similar function. They are designed to break the circuit whenever the current becomes too high, thereby stopping the flow of electricity and preventing damage or danger. A fuse is essentially a very thin strip of wire that is connected directly to the live wire within a circuit. If a surge occurs, a large amount of current flows through the live wire and therefore through the fuse itself, causing the wire inside the fuse to heat up rapidly. Because the fuse wire is so thin, it melts easily when the current exceeds safe levels, and this melting action effectively breaks the circuit so that no more current can pass through. In real-world applications, fuses are housed within small protective cases that contain the delicate wire inside, and they are manufactured in a range of different ratings depending on the level of current you want the fuse to tolerate before breaking the circuit. For example, if you are using an appliance that normally draws a current of around 3 amperes, you would typically use a 5 ampere fuse, which is just high enough to tolerate normal operation but still low enough to break during a surge. For a 10 ampere appliance, you might choose a 13 ampere fuse instead. In general, a fuse should be rated just a few amperes higher than the current your appliance normally uses. The main advantages of fuses are that they are inexpensive and simple to use, which is why they are commonly found inside many household appliances. However, one downside is that they are single-use. Once a fuse melts due to a surge, it has to be physically replaced with a new one. Circuit breakers, on the other hand, do not have this limitation. While they work on the same basic principle, that is, they interrupt the circuit whenever a surge is detected, they do not get permanently damaged in the process. Instead of melting, a circuit breaker simply gets tripped, which switches the circuit off. Once the issue has been resolved, the breaker can easily be reset without needing to replace any components, making them far more convenient in the long term, though they are slightly more expensive than traditional fuses. Another major electrical safety feature is earthing, which protects users from electric shocks if the live wire inside an appliance becomes loose and touches the outer casing, which in many appliances is made of metal. In such a case, if someone were to touch the casing, they could receive a potentially fatal electric shock. However, an earth wire provides a safe alternative path for the current to flow away from the appliance and into the ground, thereby preventing it from flowing through a person. Another common safety design is double insulation, where the entire appliance is encased in an insulating material like plastic so that there are no exposed metal parts for a user to accidentally touch. Since plastic is a poor conductor of electricity, this design drastically reduces the risk of electric shock. Appliances that feature double insulation do not require an earth wire, and they typically include only a live wire and a neutral wire. In summary, when working with electricity, it is essential to understand and apply these safety features. Fuses protect by melting and breaking the circuit. Circuit breakers do the same but can be reset. Earth wires prevent electric shocks by redirecting current safely into the ground, and double insulation eliminates the need for earthing by enclosing everything in non-conductive material. These precautions form the foundation of safe electrical design and help protect both equipment and people from the dangers posed by electrical faults and surges.